So this is clearly for Java developers on how to build rich web apps. So by having those Java APIs, what you can do, you can basically automate everything between browser and the server. So all this communication can be automated, all the rendering can be automated. So that way you can reduce your application from 3 layers to being only 1 layer and effectively slice the number of code lines in the UI to half. So for example, so if you have a, let's say, text fill and a button on the screen, you just put those as components on your Java code. This runs on the server side, you add this on the layout, and then you can use, let's say, lambdas or whatever way how you bind event listeners for those. As it runs on real JVM, you can use any language. You can use Scala, Ruby, or what have you over there to write those UIs. What happens when somebody opens up a web page on your application, he downloads effectively HTML, CSS, and JavaScript. Good thing is that these are generated by the framework, so you don't have to write this by yourself. After that, there opens up a WebSocket connection or Ajax connection, whichever you prefer, and it kind of keeps the server user interface in your server in sync with the web browser. So if you click a button over there, it sends those events back to the server side, back to your code, and they end up in your event listening code, and you can do whatever you want to with those. And as you're running on the server side already, you can call any backend API synchronously. So it's like really easy way to bridge the gap between HTML5 and Java. Then Vaadin takes over, analyzes what has changed, and sends those changes over the wire. So that was kind of simplified picture. There is a lot more in Vaadin. You can do programming on the server side in any language, basically any language that runs on top of JVM. You can do programming on the client side as well. We have built-in Java to JavaScript compiler based on Google Web Toolkit. You can program with JavaScript on the client side, so there are many possibilities. One thing that is like really recently added to Vaadin is a really powerful theming engine. So this basically makes it easy to build responsive applications that look exactly like your own kind of graphics guidelines. So with just a handful of parameters, you can change colors, roundness, depth, and make your application look like whatever you want it to look like. So this makes it so much easier than, rather than just writing CSS, you can have a set of high-level parameters to define the looks. It's Apache licensed, so you can use it for anything. And there is a huge community around it. So these guys are contributing back add-on components, and it's used really widely in big enterprises, medium-sized companies for building mostly business-oriented applications. Thanks.
Thank you. And next we have Misko from Google.
Hi, how's it going, guys? My name is Misko. I work at Google, and I work on a project called AngularJS. I started the project about 5 years ago, so I've been working on it for quite a long time. So, yeah, this is our logo. I'm sure you guys have seen it, right? Silence. Nobody?
It's on his t-shirt.
Yes. I'm sorry I don't have extra t-shirts. I should have brought some. So one of the things that Angular grew out of is really I was frustrated with the level of productivity I could be in other frameworks. And I kind of wanted to go back and say, well, what exactly is productivity? And productivity is really how much effort you put in, how much effect can you get. And when Angular originally started, it was kind of a side project for me, kind of an open source thing where I was trying to just see how much I can build without actually writing any JavaScript. In other words, how much could I allow people who are web designers, not necessarily web developers, to be able to build very simple forms that are interactive. And this is where the idea of putting markup into HTML came from. And so when you have something that's productive, it really means that it's easy to write and easy to change. And we wanted to kind of put it in a single package. And so what we have done is we have added, it all centers around this concept of declarative UI. And it comes in a lot of different forms. So on one side we have, on one extreme we have things like dependency injection, so that you never have to write your main method, and so that your application is self-assembled and easy to unit test. We have routing and animation, forms, but more importantly, what Angular really is kind of a meta framework which allows you to build other frameworks on top of. And we ship with a basic set of primitives such as ng-repeat and form validation and so on, but really it's extensible in really any imagination that you might have. And it all kind of pivots on this idea of extending the browser's vocabulary of HTML, so that HTML can now have, back to 1990, we can have our blink tag back.
Okay, thank you very much. And last but not least, we have Pete with React on Facebook. I'll just shift to it quick. That's it.
Cool. How's it going, everybody? It's after lunch, so everybody's like super excited to sit in a panel about JavaScript at a Java conference, right?
In a dark room.
In a dark room. Are we even underground right now? Some reception seems like anyway. So my name is Pete, and I love the web. And one of the reasons for that is I got paid to work on the web for a long time. So I was the team leader of the Instagram web team. I also worked on Facebook's JavaScript infrastructure team. This is the team that thinks about all of the abstractions that everybody at the company is going to use. And we can't actually force people to use our abstractions, so we have to actually make good abstractions and convince them that they're worth using. I also am on the core team of React, which is Facebook's JavaScript open source library that we open sourced May of 2013, but we've been working on since 2011. I love the web because it's everywhere. When I want to build an application, I don't want to have to build it from multiple platforms, and even though we have to deal with multiple browsers, it's still a lot easier than rebuilding in a different language with different layout abstractions and stuff like that across different platforms. But at the same time, since I make my living off of building applications on the web, I really, really hate the web a lot. I think it's a terrible API for building applications. Even when you talk about the upcoming web component standards, it's designed for building documents in the 90s, right? It's not designed for building applications. We've bolted that API on top, but it still doesn't feel like an application development platform if you used a real one. Like the Apple or Microsoft platforms or Java Swing or something like that. DOM manipulation tends to be pretty slow, so you're in JavaScript, you have to cross this bridge to C++, manipulate some objects that live in the browser, and then get the results back into JavaScript. If you manipulate them the wrong way, they trigger the layout engine to kick in when you least expect it. Oh yeah, I got ahead of myself. Layout can be slow. The standards process is also pretty slow. So the process that we have to fix these problems is really slow moving. And that's actually by design, and that's actually a good thing. We don't want to have this fragmented web where it works on some devices, doesn't work on other devices. So the fact that we have a slow standards process is good. They're trying to get it right, but it still sucks for us trying to build applications today. At the end of the day, we're not building documents anymore, we're building applications. So Facebook needed a solution. We need to build a lot of applications on the web, and we don't actually have that much influence on the platform. We don't own a browser, we don't sit on a lot of standards committees, we don't own an operating system. So we're in somewhat of a unique position. So we needed to build a JavaScript library to solve this, and we built React, which we call a library for creating user interfaces, and it changed the way that we built applications at Facebook. A lot of people think of it as the V in MVC. We don't actually think of it that way, but a lot of people use it as simply a view layer on top of an existing MVC application. And we use it in a lot of different places too. We use it on our graph search product, we use it on our page insights product, rendering data visualizations to SVG, Canvas, VML if you're unfortunate enough to have to support IE8 like we do. We use it for liking and commenting on newsfeed. This is actually the first thing we used it on. We use it on our chat product. We use it on mobile for uploading photos, our navigation. I built most of Instagram.com, and that's one big React component. So we had a couple of goals when we were working on React. We wanted to scale large teams that were good programmers, but they weren't necessarily front-end people, they weren't necessarily JavaScript programmers. We needed to get low code complexity at scale. That means that as we build more and more features, the complexity should scale linearly. We needed performance at scale, so we actually had to be able to build apps that felt good. And it should be back-end agnostic, so we should be able to render on the server without spinning up a DOM. We should be able to work across multiple browsers, that kind of thing. And we had some non-goals too. So we don't really care about embracing DOM technologies and browser technologies for the sake of embracing them. We take what makes sense and we leave what doesn't. And we're not really interested in building a familiar domain-specific language for designers. We just want the best way to build UI possible. And we think that you need to have a programming background to do that if you're building in JavaScript at scale. So we identified one key principle for making it easier to build user interfaces. And it comes from a famous computer scientist named Dijkstra, and he says we should do our utmost to shorten the conceptual gap between the static program and the dynamic process to make the correspondence between the program and the process as trivial as possible. Now that's like a wordy 1970s era computer science quote that might be difficult to digest if you're like digesting lunch at the same time. So let me try to like make it real for you. Here's our buddy list app. Now I'm going to read to you a series of changes over time, and I'm going to ask you what this should look like at the end of it. Ready? You guys memorize that? We're good? Alice went offline, Bob went offline, Steve went online, Bob went online, Charles is idle, and Charles is on mobile. What does it look like? Processes that change over time are really difficult to keep in your head. It's much easier to figure out what it looks like if you can look at the snapshot of the data at a single point in time. So basically, we build these things called data binding systems. Angular is one of the members, where a lot of the modern JavaScript libraries are data binding systems. And they make dynamic processes look more like static programs. They make it look like a single snapshot in time rather than a process that evolves over time. And this is, I don't even know what that means. The thing is that all non-trivial abstractions are leaky. So if we want to build data binding, that's an abstraction on top of like a regular programming language. And what we found is that contemporary data binding isn't simple. At Facebook, we were building applications in a similar style to how they're doing Polymer these days, with traditional data binding and a component-based architecture. And we found that it was very difficult for us to understand when our data would change, how the UI would update. And we found that if we wanted to make a user interface that was predictable, that we understood what it was going to do from a performance and correctness perspective, it had to be simple. We had to be able to fit all of it inside of our heads. And Rich Hickey, who invented the closure programming language, he says that simplicity is actually an objective thing. It's not whether you understand it or whether you're familiar with it. It's is there multiple concepts interleaved together. So it doesn't mean it's familiar. So what we did with React is we built something called a virtual DOM, which we think is a simpler, less leaky abstraction for synchronizing data from your model to your view without data binding. And I'm going to gloss over a lot of the details because this is supposed to be only 5 minutes. But basically, with a virtual DOM, whenever anything may have changed, we re-render your entire UI. But rather than re-render it to the browser itself or to the actual DOM, we re-render it to something we call the virtual DOM. Then we diff the previous virtual DOM that you rendered with the one that you just rendered after the data changed. And then we look at those differences and we only update the real browser DOM with what actually changed. And so we think that this is a simpler model for building applications. And the reason for that is your user code is a black box. It takes data in, emits virtual DOM out. You don't have to think about the transitions between all these states. Think about it as a single snapshot in time, and React will manage those transitions between one virtual DOM and another virtual DOM. So we ask you to not trade simplicity for familiarity. We have a ton of crazy ideas in our community, and we just like to experiment. So thank you.
Great. All right, thanks, guys. So that's our panel of people. Now we're going to move into more question and answer based kind of stuff. As I mentioned before, if you have, I got some questions already, but if you have questions you want to ask them, there's some pieces of paper up here. Feel free to write them down and get them to me, and I'll queue them up and pose them to our panelists. But I'll go ahead and pose the first question to our panelists to get things going. Pete just mentioned this idea of Joel Spolsky and his idea of leaky abstractions, that every abstraction is leaky to some degree or another. And of course, all web frameworks are an abstraction over something. There's another kind of similarly related law that's much less familiar to most of you unless you just happen to have read one of my books that we call Dijkstra's law. And let me explain what this is, and then I'm going to ask these guys how their frameworks react to this. So a long time ago, I worked for a consulting company, and we built a lot of Microsoft Access applications. And we eventually stopped doing that because we realized that every Access application started with a really screaming success, and they all ended in total failure. But we wanted to understand why that was, and so we codified this thing called Dijkstra's law because Terry Dijkstra was the guy who was doing all this stuff with Access. And what we realized was, when you're using a framework like Microsoft Access, that 80% of what the user wants is really super fast and easy to achieve. And they're always stunned at how fast you can get it done. The next 10% of what the user wants is possible but difficult, because you have to get underneath the framework and kind of bend it or hack it or do something it doesn't really want to do, but you can kind of convince it to do it. But the last 10% that you try to achieve is impossible with that framework, and that is Dijkstra's law that users always want 100% of what they want. This is why we don't have fourth generation languages anymore, because those abstractions didn't allow you to get underneath them enough to actually build really useful things. And so the question I'm going to pose to our panelists, let each of them respond to this, is how does your framework respond to the kind of dual forces of the leaky abstraction Spolsky's law and this idea of Dijkstra's law about having a framework that allows you to get to the right level of granularity to be able to build things?
Well, at JSF, we try to push it as far with that 80% case by just being really good about listening to what the community says and really knowing what kind of apps our framework is well suited to build. So from the beginning, we wanted to focus on corporate developers that were building enterprise intranet apps that were focusing on the needs that they had in their department, and that was the sweet spot. If you wanted to scale it up and build larger, more complex things like eBay, we wanted to be able to go there as well. But we try to stay in the sweet spot of the corporate developer. Now, when you do get to this 10%, when you can't meet the needs using the regular abstractions, because we're based on Java EE, we do have the ability to drop down into the servlet layer. But that's sometimes you get into some more trouble, because when you take the reins yourself, you are sometimes fighting with the framework, and that's something that you just kind of have to watch out for. But it requires a more advanced level of skill to do that. But people can do it with JSF, and they have been doing it for a long time.
So I think that abstraction is the power in frameworks. In Vaadin, we have 2 layers of abstraction on top of HTML5. Of course, everybody can write things directly on HTML5, but we want to kind of guarantee to you that if you're using Vaadin components, they work right. You don't have to kind of think about browser differences. You don't have to think about layouting. You don't have to think about whether there is a proxy that cannot do WebSockets in between your browser and your server. So if you're writing things on the server side, it's super easy to write out of those ready-made components. But at the same time, this is a compromise. You are giving up some power on details, how the communication happen, on how these things are rendered. And if you want to take back that power and that control, then you can drop down one level in abstraction, keep programming in Java, but program on the client side. So we have a compiler that compiles from Java to JavaScript, and it abstracts away from the browser differences. If your IE happens to leak memory, it takes care of that. So you don't have to work directly with the browser, but you have full control over the DOM. So if that's not enough, you can go down one more level and directly manipulate DOM, directly manipulate CSS, and directly deal with all the browser differences and challenges. But then it's up to you. So we have 3 levels, and I think that by having those levels, you get a lot of productivity out of that.
So when we think about Angular, I think most of we think about the directives we have, NGRP, ngModel, and that is the highest level that most people think about. What is not maybe widely known is that these directives were written on top of what we call the HTML compiler, which allows you to write your own directives. And the directives we ship in Angular are in no way special. We just wanted to make sure that you, as a developer, could also write them as well. So all the API that you need to build complex things like NGRP is actually available to you as a developer as well. So the 80% is using main to repeat. You can drop down one level low, layer low, and you can use your use the directives to make up a new vocabulary for your browser. And if that's not enough, you can certainly go down all the way to HTML, all the way to the browser, and you can just do things the old-fashioned way using jQuery. To really allow you to do stuff in the jQuery world, you really have to make sure the framework is well behaved so it doesn't take over the browser. And that goes kind of to the other point is that a good framework is one to which you can slowly ease into rather than one that kind of takes over and says you will do everything our way. And so we always wanted to make sure that you can, for example, you can have two instances of Angular on the same page and it will still work. So there's a lot of facets to the question, but it has to do with different layering as well as just playing nice with other objects, not taking over the global properties like the layout and so on.
I think Misko is absolutely right. It's all about being able to peel back layers of it and punch into the internals. So does anybody here think that framework is a dirty word? I think there's definitely people out there that think that. All right, we can see like a couple of tentative hands.
You don't have to be shy. You're among friends.
Well,
So-
that's spoken by the guy who wrote a library rather than a framework, right?
So I don't even know what framework or library means. So what I think people don't like are like poorly architected systems that like sometimes are branded as frameworks. This is gonna sound like I'm trashing on Rails. I'm not trying to trash on Rails, but Rails was designed. They were thinking, okay, how do I want the end user as the developer experience to be? Okay, I want to define my models like this, and I want to define my views like this, and we're just going to make that user interface happen. I think that's the wrong way to design a system, because you're always going to want to get beyond that easy-to-use initial interface and punch down into the lower levels, right? Like Active Record is going to do a slow query sometime. You're going to want to be able to short-circuit that. But when you punch down below those internals, there might be some decisions that they made in that public interface that make the internals really nasty. And if you go look at the Rails security vulnerabilities list, you'll see the downsides to having that public interface. So the approach we took with React is rather than say, okay, we want the out-of-the-box experience with React to look like X, we said, okay, what is the fundamental primitive building block that makes sense and is very generalizable? And we said, okay, just a component where we give it some data and it always makes sure that the DOM node is up to date. And then, okay, what's the next level of abstraction we can go on top of that? Well, components that are composed of other components. And then, okay, what's the next layer of abstraction that we can build on top of that? And then we said, components that are stateful, that can have state transitions. And then we thought to ourselves, what's the next level of abstraction on top of that? And we couldn't really come up with anything, so we shipped that in our open source release, and now the community is starting to build the next layer of abstraction on top of that. So I think if you build a framework from the bottom up rather than the top down, you'll have a much better experience when you peel back those layers.
Okay, so I'm still trying to solicit questions from you guys. Write them down on a piece of paper, bring them up, don't be shy. I know it's
I have a question.
Yeah,
What's the difference between a framework and a library?
there you go.
Well, from my perspective, the framework is something that calls you, and the library is something that you call.
So the way I like to think about it is who gets to write the main method. Right? In a library, you as a developer are fully in charge, and you call the jQuery whenever you feel like it's convenient for you. And this is very much reversed in the world of frameworks, where the frameworks own the main method, and they will call into your details of the application.
The funny thing about frameworks and libraries is when you get to the question of dependency injection. And I don't know if lots of people know this, I certainly didn't. And speaking from the audience of Java developers, dependency injection is something that you fully support in Angular.
Yes.
So, but you can't do dependency injection unless the thing that's injecting into you is the thing that owns the main method, right?
Not necessarily. I mean, Juice is logically a library. You call Juice, kind of bootstrap yourself, and it's kind of walks the line. Yeah, it's sort of. Yeah, it's kind of a gray area.
I like to think of frameworks as, well, your program is a collection of modules, right? And if one module in your system wants to use another piece of code, whether that piece of code is a library or framework, I think, depends on how the coupling between your modules changes. So A good example is if you want to use jQuery in one of your modules, that module just uses jQuery to manipulate the DOM, and it doesn't need to tell any of the other modules that it's using jQuery. If you're using something like Backbone, which is actually often touted as a library, not a framework, you end up passing Backbone models around your entire application. So in a lot of ways, this thing that is called a library infects the rest of your application because now all of your domain models are dependent on this library rather than dependent on this library, which one could argue is a framework. So the coupling between different pieces of your program changes when you add Backbone or a larger scale framework into your system.
So it actually brings me to an interesting point, which is that when you're building a web application, you can pick and choose as many libraries as you want to put in your project, but you typically are restricted to just one framework. Typically frameworks don't like each other because both of them want to take over the main method.
Frameworks don't compose well.
Typically not. Although with Angular we tried very hard to make it as composable as possible given the constraint that we're working.
They could have got different layers, but I mean, Vaadin, it's a Vaadin framework, and we have been calling that Vaadin library, or it was a Millstone library before that, and I think it's kind of confusing to kind of speak about libraries and frameworks, so the differences are so subtle that I think world would be a much better place if we could all agree that there are no frameworks, we are all just libraries over here.
But that brings up an interesting kind of difference between some of the frameworks up here. And of course, this is a Smackdown, so we're kind of interested in poking around at the differences. The modularity works very differently in Java than it does in JavaScript. So the broader question is here, how is the implementation language you're writing these frameworks in? How does it flavor what you can do with the framework and how usable it is and how tooling works in that space, etc.? Discuss.
All right, well, I think the tooling question is something, a big difference between the two stacks that we have up here. And I know when I started trying to look into Angular, that you quickly run off into Bower and Grunt and Yeoman and all these other things that are basically IDE type tools that you do at a command line, whereas in the Java world you have these IDEs that people are more familiar with dragging and dropping of components and automatic refactoring and such. Yes, and building, right? And how modules work. I mean, that does clearly infect how you structure your whole application. So they're two very different worlds. And so while we're only talking about the web framework piece here, as soon as you buy into any one of our stacks, you really are buying into a big ecosystem of other kinds of things that affect the software development process.
I think it's mostly a question about static and dynamic typing. So the language has to have static typing that offers a lot of possibilities for tooling. And being on the Java side of the table, I really believe that the static typing is the key for building systems where you have larger groups of people working on those systems and maintaining those systems and not ending up with a bunch of spaghetti in this other project.
That comes back to the notion of just knowing what your users are. I mean, if your users are banks and corporations and they're trying to deliver systems that are just very well defined and they need to last for a good 15, 20 years and they're not going to change. And even more importantly, the people that are using them are paid to be using it, so there's no value add in making it really nice and flashy and good. It's not a competitive advantage for the product you're trying to sell, then that gives you a bit more constraint in what you can do, but also makes it easier to build solutions for it.
So typing is a kind of a double-edged sword. I can see both sides. I mean, I came from a Java world originally, and I thought the typing was a big piece. Then I lived for a while in JavaScript world where the types disappeared and you had to force yourself to rely on tests. And you can definitely see both sides of the world. And there needs to be some happy medium where sometimes types are worth the trouble and sometimes they're not. It reminds me of an old joke, which is that types are exactly what it says a lot of times.
Well, we tried to experiment with this approach in JSF a long time and it really never quite caught on. But the idea was you could write all of your model objects and even your UI components in a more loosely typed language like Ruby. And then as you went along in time and understood your design better, you could sort of rewrite the stuff piece by piece in Java and have the typing there. But we've had this feature for many, many, many years, and not very many people have been using it.
That's kind of the conclusion that we came to at Facebook as well. At least on the server side, Facebook's a very famous PHP shop. for better or mostly worse. But what we discovered is like PHP let us move really fast. We didn't have to worry about the compiler asserting that all of our type system was consistent, which is great when you want to gradually approach this solution. You're not sure what you're building, and you just kind of want to run it, make sure the UI looks good, make sure the interaction feels right. But when you get up to scale and when you start getting regulated by governments about whether your privacy checks pass or not, that's a big deal, and like static typing can help you a lot. So we were able to invest in a new programming language called Hack, which is gradually typed. So you can leave off type annotations and it'll treat it more like a dynamically typed system, and then you can start adding type annotations and eventually get to full type coverage. I believe, I don't really know Dart, but doesn't Dart do a little bit of type inference and stuff like that?
It is a mixed world where the types are optional. It's a pretty good world.
Yeah, it's been successful for us too. And TypeScript by Microsoft is bringing that to JavaScript as well. We just announced one for JavaScript too. It's a little bit different.
So I guess my experience is kind of opposite to Misko's. I come from a dynamic typing world. I was leading a team like 15 years ago that built pretty big web application with Perl. We had like 200,000 lines of Perl code, and we were super fast in building that. So we hacked it together, and oh my goodness, it's horrible spaghetti. Nobody can maintain that code base. So that was an inspiration to kind of, oh my goodness, we have to build better tools for this. So the next try was go to Java world, start to build everything out of Java-based components. But we still built the client side that renders those components in JavaScript. So the server side succeeded, client side was again horrible hack. I mean, it worked pretty well, but none of the users could actually extend that because it was practically impossible to refactor. It might be that we had bad coders in our team, but that was the reality for us. So I'm actually quite strongly for typing. So I think it's really, really good thing that you have strong typing in your application. And that if you look languages like Scala, you can make it really flexible and nimble even with types.
So can we talk about something less controversial, maybe Emacs versus VI?
VI.
Emacs.
Emacs.
I thought it's all about the Eclipse these days, no?
So a couple of questions that I got from the audience actually, and I'm still welcoming more questions, is about particular entities and in particular testability. How testable, was it built as an initial goal? How testable are your frameworks now?
Well, the testability of JSF comes in part from the testability of Java EE, and that comes from the separation of concerns that was really popularized with dependency injection and being able to use plain old Java objects to control your model system, and therefore that makes mocking very easy. We also had some testability in terms of being able to exercise the UI as well. So when you have components that are just controlling their own little part of the page, you can make assertions about what they should look like and how they should behave, and that's something that we do also well in JSF.
So for Vaadin, being on the Java side, of course, everything on the server side is testable by JUnit tests. So that's like quite natural. But I think it's not enough. So in the end of the day, your users see something on the screen, and maybe somebody in your team is at least kind of does something that he shouldn't be doing with the CSS, and that breaks IE9 or something like that. So we also have a test tooling on the client side called Vaadin Test Bench based on Selenium and Hevery can test and other things on both on the DOM level as well as on a pixel by pixel level. And these are packaged as JUnit tests as well.
So testability is one of my big things. I don't know, some of you might actually heard of me before Angular as the guy who was running testability work at Google. And the job we kind of had was to bring testing to developers. So we would join teams for like 6 months, and we would show them, how you could refactor testability through dependency injection, etc. So when it came to Angular, when I started building Angular, testability was very much high priority for me. And so there's a lot of different levels of testability. You could write your framework in a way that you yourself can test it, and there's a whole different aspect of writing a framework so that others are automatically guided towards testable code. Because you could make a framework that you yourself can test the framework, but it doesn't mean that the developers who write against the framework will have easy time testing. And this is something that I was kind of hoping that a lot more libraries and frameworks would take to heart, and when they build their frameworks, really thought about this from the very beginning. So for example, a lot of decisions we did in Angular are affected by this. In Angular we have a controller, and controller may inject scope, but it's very important that the scope doesn't have a dependency on the UI. So in Angular you can instantiate the controllers without HTML ever being present. And this is one of the very important points which we wanted to build into Angular so that the testability becomes trivial. There are no inheritance that you have to do in Angular. It's all about composition. Those are all properties that, through battle we have discovered that these things are indeed the testable stories. So we think Angular's testability is really one of its key features that it provides. Now, this is all kind of on a unit testing level, but there's also an end-to-end testing level. When you're building a web application, you click on a button, and you want to assert that a particular text is shown up, you have this particular problem, which is that you don't know how long to wait before you can read. And so there's all kinds of strategies people do in terms of waiting and so on. And it gets further complicated because the data might be coming from the server and you know how long to wait, etc. So not only do we have a beautiful unit testing story, but we also have an end-to-end story where we have this thing that runs on top of Angular called the protractor. And the protractor's job is to kind of understand how Angular works internally. So when you say, click this button, you can immediately say, what looks to you as a synchronous code, you can say, assert that this particular thing has changed. What it actually does underneath is it builds up a state machine and figures out, okay, there might be a delay between this point over here. It counts how many XHRs go out. It understands how Angular does its rendering cycle, and so it waits until the whole thing is finished before it goes and inserts. And the end result of that is that your tests are a lot less flaky and they run a lot faster because the checks happen exactly right after the render. So yeah, testability is one of my pet peeves that I really love to talk about.
So as far as React goes, I mentioned that we hedge against the back end so we can render on the server, in the browser on multiple different UI toolkits, that kind of thing. That actually makes testing components a lot easier because you just call your render method, it returns this virtual DOM description of what you want to render. It doesn't actually touch the browser backend at all. So there's no dependency on the actual browser DOM. So your test execution is pretty quick and it doesn't depend on kind of the quirks of this particular browser DOM implementation that you have. With that said, that doesn't cover 100% of testing cases. Like you need these end-to-end integration tests like Misko said. Actually, the favorite bug that I ever had at Facebook was an intern removed a line of CSS that set the height of all of our images on our mobile site to 0. So the JPEGs were getting served and like everything looked good, but in our test pass, but we were just getting lots of bug reports, and a really, really strong integration testing strategy may have caught that. But there's all sorts of classes of bugs. But one interesting thing that we did do on the JavaScript side, we open sourced a JavaScript testing system called Jest. And if you're familiar with Jasmine or RSpec or one of those types of testing tools, sorry, not RSpec, maybe it's RSpec, I don't know the Ruby one. But it's a standard unit testing system for JavaScript, but the key difference is that require, which is JavaScript's version of import, by default returns mocked or auto-mocked versions of all of your dependencies, and you explicitly opt out of mock. So normally when you build a system, you say, hey, actually I want to mock my user service or my persistent service. With Jest and the way that we write unit tests on the client on Facebook is we have through the magic of reflection, we import those modules, we generate mocks that look like those public interfaces, and then they just return mock representations of everything. So that means out of the box, your tests are fast. I'm not necessarily sure that I agree with that because I'm not really sure what you're testing at that point, but that's one of those things that is always being debated internally.
So I'm going to avoid asking a question that would terrify the panelist, which is, what's the most glaring weakness of your framework? Instead, I'm going to ask a related question. This is optional. You can answer this question if you'd like to, but a more pertinent related question, I think, is, are there particular sweet spots for your framework? Is it better for a single-page app or enterprise app? And there is a mapping between a framework and a type of application that You may not be building things like Facebook is building, so it may not be suitable for you. So what is the really sweet spot for your particular framework, and is there a sweet spot for the kinds of things you're trying to build in?
Let's not just go down. Let's
Sure.
What I'm saying is,
So we'll start at the other end this time.
I'm going to go back this one.
no, I think it's enough.
So originally Angular, the idea for Angular was like, can I just simply add some markup into HTML so that a web designer who doesn't necessarily know how to program can make an interactive form. And so I think the strong point of Angular has always been around forms and CRUD, which is create, update, delete. It means you get data from the server, you render it to the user, user somehow interacts with the data, and then you share it back to the server. So the strong points really are, we can get it to XHR, we can get it from the browser's memory, we can data bind it from the browser's memory to the UI. The user can interact with it and ship it back to the that would be the strong one. For the weak one, I always thought that things that require very rapid, continuous access, like for example games, would maybe not be the appropriate thing for Angular. But since I've been proven wrong on that account many times too, because people seem to also build games in Angular, which always shocks me. But I wouldn't consider it to be that.
Spolsky's rule, which seems to be coming true, that if it can be written in JavaScript, it will be written in JavaScript.
It is true. That is true.
So I obviously have a really big bias here, but I think that that React has stumbled upon a fundamentally better rendering model than any competing environment, period. With that said, I don't necessarily think that React is the be-all, end-all of creating applications. I think the fundamental ideas of describing your UI as a function in any point in time is a good one. But you can crank out a simple application in Angular probably quicker than you can in React, and your designers won't want to shoot your engineers in the face if you're using Angular, as opposed to the first time they see React code, because it's very oriented towards engineers and JavaScript developers rather than people who are more familiar with markup. So I think that we excel right now at building really complex user interfaces where you have to really get that last 10% of performance or 10% of specific interaction. I want to bounce this thing only when I pull it 50% of the way or more on the screen or something like that. But I think the fundamental ideas should be absorbed into all other UI toolkits that are targeting different use cases. So I just think that they're really, really good.
So I think what should be going to recognize is that different needs need different kind of frameworks. So if you're going to be building next Facebook, please don't use Vaadin. It would be going horribly wrong. The sweet spot for using Vaadin is basically those enterprise applications where you're replacing something that those enterprises are running already. And with that I mean application. More you have a complexity in your application, more you have user interface in your application, longer you expect your users to use that application on a daily basis, better it comes for Vaadin. And more you have to kind of rely on a small team to build big application, maintain big application. That's a better and better use case for Vaadin. So it is for building component-oriented applications. But if you're going to be building end-user facing pretty static website, please use Spring MVC or something like that instead of Vaadin.
So I already mentioned the sweet spot for JSF being the enterprise with large teams of corporate developers that have they're either junior or mid-level skill sets, not top of the line, really expensive developers in the junior or middle level. And a clear separation of roles between the people that are writing the code and the people that are designing the UI. Those people also that are designing the UI, they need to have the right kind of skills that they're not exactly JavaScript experts, but they're more kind of page development experts. So they are still distinct skill sets. They've been coming together over the last few years, but I still think a JavaScript developer who designs is different from a designer who also does some JavaScript. As far as weak spot for JSF, I would say it's a little, it can be too easy to build an application that has some memory constraints that doesn't perform as well with memory, because things are so convenient to use some of these facilities we have in JSF, like the session and the view state, that it's possible to build poorly performing apps without trying too hard.
Maybe just to kind of continue on that, So you were also mentioning single-page application versus multi-page applications. In Vaadin, everything is a single-page application. So if you're trying to build a website with many pages, and I mean like real pages, not just like states on one single page, it wouldn't go too well. But if you're building a single-page application, it works right out of the box, and it uses push right out of the box, so you don't have to do anything to kind of enable that kind of application style.
There's another question for the crowd. How well are your frameworks embracing like new standards that are coming about, like for example web components, which should generate a nice rant from some of the people on the panel here? What do you feel about brand new things that are coming on the rise and are going to have an impact on your ecosystem?
So I remember a long time ago I had a meeting with Dimitri, who is the Google's founder's body, and he says, at that point Angular was just kind of getting going. He says, my job is to make sure that Angular is not needed in the future. And so I like to think that the way I explain it to myself is that Angular has influenced it. And I think there are some ideas that we have in Angular that is actually made it. Now the web components are becoming a standard, which is also, unfortunately, the roles are kind of reversed, and we have to start being able to consume web components as well. It's probably too late for Angular 1x to be able to consume web components, but when we have rebuilt Angular on top of Dart, we wanted to make sure that we are running on top of web components, so we can, for example, consume Smackdown already and get a lot of use of it from Angular Dart. And now all these learnings that we have gotten from we're funneling it back into Angular 2.0. In 2.0, the goal is to be able to use any web component, and all the data binding should be indistinguishable whether you are data binding to an existing Angular component or you're data binding to a web component underneath. And also we wanted to make sure that Angular can export itself as a web component, so not only consuming but also exporting. So going forward, we very much like to embrace the future of the web.
Well, web components is just one part of it. There's so many other aspects like WebSocket, service and events, Canvas, and when you have this UI component abstraction model that we have with JSF, you're able to, for example, take advantage of Canvas. If you don't have a JSF component that's using the Java, the Canvas 2D drawing object, you can go ahead and do that. The WebSocket and the JSON and the other kinds of things that are doing there, that's just a part of what we have in Java EE. So by building on top of Java EE, we're letting you take advantage of that in your apps. And that's not specific to JSF, that's just Java EE.
Before I start ranting about web components, ES6 is the upcoming version of JavaScript, and it's been coming like real soon now for the past couple of years. But there's a lot of tools out there called ES6 Transpiler. Google has one called Tracer. Did I pronounce that right?
No idea.
I don't know.
I always struggle.
I look at you like you have every answer to everything Google. We have one called JS Transform, and they basically let you use like traditional classes rather than having to figure out like what the stupid prototype thing is. You can do generators in the upcoming ES6. What else is in there? Destructuring assignment, arrow functions, just like a lot of nice syntax borrowed from CoffeeScript. It's kind of like what Groovy did for Java, except there's very little semantic changes. It's just kind of a more concise way to do some things. But I'm not really excited about, so we're all really excited about ES6, I think. I know that Angular is using it, I know Ember is using it, React is using it, pretty much everybody's using it because it's a big win. Web components, I feel, are they're solving one great problem, I think, which is being able to customize the native form fields. So if you want to change the way a select dropdown behaves, like that form component in the browser, you have to re-implement the entire thing in HTML, CSS, and JavaScript. And Facebook did it, and it's like 4,000 lines of code. And that means getting accessibility right, making sure it works on all these different platforms. And now that like mobile is a thing, we have to rethink all that too. So Shadow DOM, which is one of the family of specifications under the Web Components umbrella, lets us customize that. And I think that is really, really great. So we can finally throw out all that code and customize what a select looks like. That's amazing. But the goal is to basically kill off the need for JavaScript frameworks and build a better application development environment in the browser. And I think that's a really dangerous idea for a number of reasons. Number one, it continues to tie us to the DOM and the web family of technologies, which again, were designed for documents. And we're starting to evolve it away from there. But evolution only gets us so far. I think we have to throw out a lot of this stuff and start from scratch. If you were to build a UI toolkit, it would look nothing like the DOM. The second thing is like we don't have all the answers yet to the right way to build in the browser. They're basically baking in best practices of 2009, and React likes to think that we've found some new best practices that shouldn't necessarily be baked into a standard that we have to live with forever. And the final thing is just kind of philosophically baking an application development toolkit, like the SDK that end users are supposed to use, into a browser that's distributed to billions of people that has to be, every time you want to make a change to it, you have to go through a standardization process that takes forever. Do you think that's ever going to lead to an SDK that can let us build cutting-edge applications? Or do you think the Apples and Googles of the world that control the Android and iOS platforms can roll out frosted glass in a year? Are people even thinking about a standard for frosted glass on the web? I don't know, but it's really hard to build that effect if you want to look like a native application on iOS.
So, I was going to say that it's an interesting point of view. I actually haven't seen that. What I've seen more in all these standards is how we build primitives, such as object observe or shadow DOM. And these are primitives that are, first of all, much easier to standardize, and also they're more useful into a lot of different things. So as far as building primitives, I think you can agree that primitives are probably a good idea.
Yeah.
As far as building frameworks, I totally agree with you that that is certainly not what the platform should do, because frameworks can be evolved much faster without standards. I don't think anybody's trying to do that. I think there might be some naming confusion because people name things the same way, but I don't feel like the web standards are trying to take over the framework. I think really they're just providing primitives that can be consumed by others to build other good things.
So,
Maybe.
if I may continue from this aspect, it looks like we are only running out of time. So basically, what is a component-based framework? And it basically promises to you that it makes a web application development easy. And now there is this upcoming standard, web component standard, that has exact same promise. Of course, different language, so it's not the same thing. But that kind of sets these two things to be on a collision course, right? Except that you cannot use web components today. Your users don't have browsers today. I mean, all of the users that could use and consume those web components. So we have a bit of time, and I think when your users can use those web components, Vaadin is pretty much merged with and aligned with that standard. I mean, we will be able to produce web components, consume web components, or actually you can consume web components in Vaadin already today. But when you can start using those components, you can program with Vaadin components and assume that these are web components actually.
Okay. I think we are now officially out of time, so join me in thanking our panelists.